Hello. So, coming back to today's problem of the day question. So, the name of the question is Toeplitz matrix. You can find on GFG. I'll paste the link. So, let's understand the question first. So, a Toeplitz matrix is a matrix in which its descending diagonal from left to right. Point to be noted is left to right is constant. That is, all elements in diagonal are the same. So, basically, all the elements in the diagonal in a diagonal should be same. So a matrix will be given. I need to just return true or false. True if the matrix is a Toeplitz matrix, and false if it is not. So let's understand how will we proceed. So first the question says I have to suppose these are the matrix. This is a matrix of 4 cross 4, 9, 10, 11, 12, 13, 14, 15, 16. So this is the matrix. So I need to check if the diagonal from left to right. For example, this is a diagonal. Again, this is a diagonal. This is a diagonal. This is itself a diagonal. This is a diagonal. This is also a diagonal. And this is a diagonal. I need to check the elements in a particular diagonal should be same. For example, 1, 2, 3, 4, 5, 1, 2, 4, 1. This is a Toeplitz matrix. Why? Because in every diagonal, for example, in this diagonal, all are same. Similarly, in this diagonal, all the elements are same. Similarly, in this also same, and in the last we have only one element, so it doesn't matter at all. So this is the Toeplitz matrix. So I have to find whether it is yes or no, that is true or false. So how will we proceed? Maybe you have understood the part. So let's mark my, suppose this is my matrix. So these are my row elements. Yeah. So let me show you how will I proceed. Okay. So suppose this is 0 comma 0. So for getting to the next diagonal element, we know for any I comma j, suppose they are the indexes of any cell. To get to the next cell, I mean the diagonal cell, what we do is basically I plus 1 and j plus 1. So here also we will do the same logic. What will I do is basically I will iterate over this many elements and find the diagonal of all these elements. For example, for int I equal to, like, yeah, here only the column is changing. So what will I do is, like, uh, I will iterate over the column and I will keep the row constant, and I will do a while loop and check whether there is any diagonal element whose value is not equal to the starting value. Let me explain you with the code that would help us to understand. Yeah. So yes. So let me explain. So like always, I have declared my row size with m and column size with n. So now this is my uh, okay. This is not that one. This is the first what I was saying. For int j equal to 0 to j equal to n is the total number of columns, j plus plus 1. So I will go to the next adjacent diagonal element, and the row value will be 1 and the column value will be j plus 1, and I will put a while loop till when row is less than m and column is less than n, because these are the maximum uh, size of the matrix. It cannot go further. So if at any place my cell is not equal to the diagonal cell, uh, topmost diagonal cell, then it should be return false. And if it is not, then row plus plus, column plus plus, to proceed to the next diagonal element. So let me explain you this part. What this part is meaning. Okay, so can I? Yeah, I can make it smaller. Yeah, no, around 16. Yes. Okay. So Okay, so this would put a issue. I need to put somewhere here. Yeah. So now I am on place. Now I'll show you what I am trying to do. Yeah. So for in j equal to 0, j less than n, j plus plus means I am iterating over this row. Why? Because first I will find this diagonal, then I will find this diagonal, then I will find this diagonal, and finally this diagonal. How I am doing this? Like suppose 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I am iterating over these many elements, right? So the value of this row will be always 0 because this is the zeroth row. What is changing is the column number. So I am iterating the column until what I will iterate till n. So I have like for example for any for j equal to 1 where I am here j equal to 1. So my row will be 1 because now I will start checking from the next diagonal element, and that diagonal element would have row value 1 because this is row value 1. So I will be here, and how I'm getting here, since j equal to 1, so my column number will be j plus 1, and I am checking with the matrix 0 comma j. This is my reference point. I am checking every diagonal to be same as this. If at any place this is not same, if matrix of row column is not equal to matrix of the starting element of the diagonal element, then return false. So this is my logic. And similarly, once I am done covering the first topmost triangle, I will now iterate over this part and try to find this with the same logic. So let me show you that part as well. Yeah. So this is the row part. Here the column will be 1 because now we will go to the next column while traveling to the diagonal, and the row will change. And this is the same logic as well. Yeah. And if we do not get any flaw, I mean if we do not get any false in the entire matrix, then we will return true. So let me run the code. Yeah, so this is working. All the test cases are passed. Please ask me if you have any doubt in the comment section. I hope it's clear. Thank you.